Hey everybody, this is Larry. This is day 23 of the Leetcode Day Challenge, and we didn't do the weekly premium farm yet, so let's get it today. Okay, today is a kind of an easy one. It seems like 242, power of 4. So, good time to take a break mentally. Hopefully. Um, yeah, so, I don't know. Is there anything difficult to say? There are a couple of ways you can do it. Can I solve it without loops and recursion, right? Well, what does a power of 4 look like, right? I mean, I was going to say something like, they're only like 10 numbers, right, that are within these range of the constraints. So depending on how, so you just check to see whether they are in it. So I don't know. That would be an interesting way to do it. And I think sometimes you just got to do what it takes, of course. I mean, this one is an easy one. I'm using it as an example of just, sometimes you just got to do what you got to do. And sometimes they look silly, but that's fine. Who needs for loops or recursion? Just where, return n in, and there's no negative, oh, is there negative power? No, there's negative power, but there's no negative um, power of 4, right? So given a positive power. So yeah, just return 1, 4, 16. I don't know what's after that. 64. I'm gonna miss some, of course. Maybe I should just look for a thing. There shouldn't be that much more though, right? That many more. Oh, maybe they're on 10. I was thinking 2 to the 20 for some reason, but it is actually 2 to 31, so there's 15 at least. Alright, I'm going to just Google it. But you get the idea of what I was gonna oh my god, I'm so tired. No, I say that all the time. I'm actually pretty refreshed today, but I'm yawning for some reason. Alright. I'm not gonna actually write it out. But you can kind of do that way. It's still that was just to answer if I could solve it without loops and recursion. So technically, yes. Is there any other? I'm trying to think whether I remember some crazy bitwise trick, um, you know, to do it, right? What is a power of 4? So the power of 2, we know how, or I know how to do this like trick, right? Can we convert a power of 2 to, yeah. Like the power of 2, you can do something like n, n minus 1, right? Is equal to 0, right? Make sure we have the parens. So if this is true, then it's power of 2, right? Let's just name it this, right? Can we convert that to a version of that's with 4? Because basically the idea of a power of 2 is that it looks something like this, but a power of 4 is also something like this, except, so it has to be a power of 2 first, but then it also, but it has even number of zeros behind it, right? Because every four, so instead of one, or multiple of 1 zeros, you can say, which is obviously just any number of zeros, is an even number of zeros. Now the question is, how do I do this in bitwise function, or is there a way to do in bitwise functions? These are things that I generally do not need to do, both in competitive or in real life. So so it is an interesting brain teaser of sort, even for easy. Let me So the power of 2 thing is going to be true. I don't know if I was going to say like finding the square root. If it's a power of 2, then we can find the square root, And then if the square root is a power of 2, then we should be Gucci. Is that right? Is that right? Because square rooting is just basically dividing the number of zeros by 2, right? So though I mean I don't know if that counts as cheating or whatever, but but it is something that's new to me, so I'm gonna try to see if this works. It may not work. So yeah. So if not 2, return false. Right. Return to S2. I guess we end it, but yeah, I mean, I think this is fine. I mean, I'm always worried about floating point stuff, but in this case, if it is a power of 2, then there are only 2 scenarios, right? It's either a power of 2 or a power of 4. I mean, I guess there are more numbers, but if it's a power of 4, then it would be int anyway, perfectly, and if not, then it wouldn't be. So okay, so let's give it a submit. Oh no, I forgot 0. Okay, well, that's annoying. Why is this? 0 is... Yeah, I guess okay, fine. I actually, with these bitwise function, I was just focused on positive numbers, but I guess the bitwise functions are always a little bit weird. 2 is what? I guess this is where it bit me, in that the int part of the thing is not true. Because the int makes it from 1.414 to 1, and then 1 is true here. Okay, so a lot of edge cases, well, maybe not a lot, but definitely, yeah, okay, fine. I mean, you get, someone like that, right? Yeah. Oh, I didn't add it back in. Was it 1, 0, 2? It's a lot of silly mistakes. I don't even know if there's silly mistakes, but there's a lot of mistakes. But hopefully this is a cool idea. I got it wrong before, but I think that's because I tried to do something clever. Because, I mean, come on. No, I don't think I would have done it that way. Oh, I did do the square root trick before too. I thought I was trying to be clever today. And I forgot the 0 case, yep. And then I forgot the 1 case. So I did exactly the same thing really last time. Well, this 2 times ago. So I had to add this thing, which I did today as well. So okay, so I guess I made the same mistakes of the same edge cases 3 years apart. So I don't know. But hopefully this is interesting, if nothing else. Yeah, that's all I have with this one. I thought I was being smarter, or getting smarter. Looks like same level of dumbness. So yeah. Anyway, that's all I have for today. Let me know what you think. Stay good, stay healthy, to your mental health. I'll see y'all later. Take care. Bye bye.